All right, tonight I'd like to talk about solving systems of linear inequalities. I'm doing a little bit different style of video recording tonight. I've got my Elmo set up and I've got my headphone microphone on, so bear with me here. It's going to be a little bit different as I do this live under the document camera. Let's start first of all with some vocabulary. When I talk about a system of linear inequalities, I'm talking about two or more inequalities. Notice the word more. Tonight you're going to see several inequalities in a system. Anywhere from 2, 3, or 4 inequalities that make up a system, you're going to have to graph those. When we talk about a solution of a system of linear inequalities, solution being key word here, we're talking about an ordered pair that satisfies each inequality in the system. That's the same for what we were used to with linear equations. You're looking for that one point that satisfies both equations. In this case, you're going to see by the graph of a system of linear inequalities that there is a region in which multiple points can satisfy all of the inequalities. So when I talk about shading, I'm talking about defining the region that satisfies all of your inequalities in your system. You're going to see what I'm talking about next. If we look at example 1, graph the system of linear inequalities and shade the solution region. Okay, so first of all, we have y is less than 2. You guys remember prior to that a less than or a greater than indicates a dotted line, and a less than equal to or greater than equal to represents a solid line. That's important when shading because we're going to know if it's a dotted line and the point is on the dotted line, it would not be included, whereas a solid line would be included. Okay, so y is less than 2. We know that y equals 2 would be a horizontal line at 0, 2. So I'm going to go ahead and draw a dotted line here for y is equals 2. And we are talking about less than 2, so we're talking about everything that is less than this line. So I'm going to shade that blue. Okay, I'm going to switch colors here and use a green. I'm going to use a green to show you that x is greater than or equal to -1. So x is equal to -1 would be a vertical line at -1. So I'm going to go to -1 here, and since it's equal to, I can draw a solid line. And greater than or equal to would indicate everything in this direction heading toward the positive. So far you see that this is the double shaded region. It's the overlapped region. All right, now I'm going to go with red to show you how y is greater than x minus 2. So this right here is going to have a y-intercept of 0, -2, and this guy indicates that the slope is positive 1 over 1. So I'll go down to -2, 1, 2. and I'll go up 1 over 1, up 1 over 1, up 1 over 1. Continue that pattern. And it's greater than, so it's not equal to. So I'm going to represent this one with a dotted line. And that looks something like this. When y is greater than, so that's going to be everything above the line. I think my red marker is going out. So you can see here from this picture that the triple shaded, I say triple because there are 3 inequalities that make up the system. That triple shaded region is here, here, and here. So we're talking about this area inside this triangle that it forms. Any solution that is inside this triangle or on this line when x is -1 is a solution to the system of inequalities. So just for giggles here, I'm going to say that 0, 0 is inside that region. So 0, 0 is a solution to the system of inequalities. I'm going to say that 1, 1 is a solution to the inequalities. And I can also say that 2, 1 is a solution. 1, 2, 2, 1 is also a solution. You could check these points by plugging in 0, 0 into all 3 inequalities. Is 0 less than 2? Yes. Is 0 greater than or equal to -1? Yes. Is 0 greater than 0 minus 2? Well, 0 is greater than -2, so absolutely. This proves that this is a solution. You could do the same with 1, 1 and 2, 1 to prove it to yourself. All right, let's see the next example. Okay, graph the system of linear inequalities and shade the solution region. We have x is greater than or equal to 0. So I'll use my purple here. Greater than or equal to 0, so that's going to be on the y-axis here. Solid line. And it's greater than or equal to, so I can show anything in the positive x direction. If I show y is greater than or equal to 0 in green, I'm going to turn this way, and that's going to be on the x-axis, and I can show greater than or equal to by anything in positive y direction. So here we got a double shaded region going on, so it's going to be somewhere in this area, I'm guessing. Y is less than or equal to 2. That's going to be a horizontal line at positive 2. And we're talking about less than, so that's going to be this direction. Okay, so here we have a triple shaded region in this rectangle right here. And lastly, let me show you y is less than or equal to negative 1/2 x plus 3. So this is going to indicate a y-intercept of 0, 3, and this is going to indicate a slope of negative 1 over 2, so down 1, right 2. I go to my 0, 3, down 1, right 2, down 1, right 2, down 1, right 2, and so forth. And then I'm going to show that y is less than or equal to, so that's going to be a solid line. And my line could have been a little bit better, but less than or equal to is going to indicate this area. So if I'm looking for the quadruple shaded region, the region that has all 4 colors, I am talking about here, 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 and here, and they're all equal to, so I can talk about the lines in which they lie on as well. We are referring to this trapezoidal region here. So if I had to name some points that were a solution to this system of inequalities, I could say 0, 0. I could say 2, 1. I could say 1, 2. And the list goes on and on and on and on and on. But let's prove that this guy is a solution. If x is 1 greater than or equal to 0? Yes, it is. If y is 2 greater than or equal to 0? Yes, it is. Y is 2 less than or equal to 2? It's equal to, so that works. And then is 2 less than or equal to negative 1/2 times 1 plus 3? So that's going to be 2 less than or equal to negative 1/2 plus 3 would be 2.5. Is 2 less than or equal to 2.5? Absolutely. So this is a solution to this system of inequalities. Okay? I would like for you to pause the video, and I want you, using the last one that we did as a model, to graph this system of inequalities with multiple colors, shade your solution region, and then I want you to name a solution and check it mathematically. Okay, so go ahead and pause your video, graph the system, shade the region, and then name a solution and check it mathematically. Okay, now that you're back from checking, I have shown you what colors I graphed and shaded each of the inequalities. I defined the shaded region for you here as this trapezoidal box. I shaded it in, and because they're all equal to, I have 4 solid lines around that region. I named the solution 2, 0, which is right here, as being in that solution region, and I checked it by putting 2 in for x and a 0 in for y in each of the inequalities, and it checked out. So this is in fact a solution to this system of linear inequalities. If you want to pause the video for a second just to make sure that yours looks like mine, please feel free. All right. The next one I have is a word problem, which you guys are probably relieved to see me do a word problem with you all. It's a little more of an application style problem, something we're not used to on videos, but I thought it would be nice to cover how to do word problems with you all in this lesson. So you're ordering lighting for a theater so that the spotlights can follow the performers. The lighting technician needs at least, there's your inequality term, at least 3 medium spotlights and at least 1 long throw spotlight. A medium throw spotlight costs $1,000 and a long throw spotlight costs $3,500. The minimum order for free delivery is $10,000. So the first thing we need to do is write some inequalities. And I'll tell you to begin, I think we're going to have about 3 inequalities here we have to deal with. We know that we're talking about medium throw and long throw spotlights. So we can go ahead and define our variables. Make X be medium throw spotlights and let Y be long throw spotlights. And we know from our word problem that we have to have at least 3. So X has to be greater than or equal to 3. Can't be any less. And Y, the long throw, has to be greater than or equal to 1. At least 1. You can have 2, 3, or 4, so on, but you have to have at least 1. The next thing that we have to make an inequality for is the cost. We know a medium throw is $1,000 and a long throw is $3,500. And in order to get this special delivery, our medium plus long has to be a minimum of 10,000. So that means it could include 10,000 or more. So I think that's going to look something like this. $1,000 for a medium throw plus $3,500 for a long throw has to be greater than or equal to 10,000, sorry. In order to be able to graph this, I need to get this in slope-intercept form, so I'm going to subtract 1,000x from both sides. And I have this. And then divide by 3,500. That's going to leave me with y is greater than or equal to negative, let's see, 1, 2, 3, 1, 2, negative 10 over 35x plus 1, 2, 100 over 35. Okay, so I simplified that to y is greater than or equal to negative 2/7 x plus 20/7. Okay, so I need to graph this, and this inequality. They're the ones that make up my system of linear inequalities. Let me scoot that up just a little bit for you. There we go. So first off, x is greater than or equal to 3. We know that's going to be a vertical line at 3. So 1, 2, 3 right here. I'll do that in orange for you. It's greater than or equal to, so solid line. And that's in orange. And then y is greater than or equal to 1. Let me do that in purple for you. That's going to be a horizontal line at y equals 1. It's equal to, so I can draw a straight line. And then I'm going to shade above. Okay, so far our region's going to be somewhere in this area. And then lastly, I've got this bad boy. 20 divided by 7. 20 is going to go in there 2 times evenly with some change. If you do 20 divided by 7, you get 2, 14, 6 left over. 7 won't go into 6, but if I add a decimal and a 0, 7 times, let's see, 6 is 56. There's 4 left over. Oh, I'm sorry, that should be an 8. 7 times 8, my bad. Know your multiplication, Laura Beth. 7 times 8 is 56. 4 left over. If I add my 0 and bring that down, 7 times 5 is 35. 5 left over. I could keep this going, but it's going to be somewhere around 2 and 85 hundredths will be my y-intercept. And then, I'm going to put it at here, 0, 1, 2, and a little bit more than half. And then I'm going to go down to right 7. 1, 2, right 7. 1, 2, 3, 4, 5, 6, 7. Somewhere in that vicinity there. I've got 2 dots, so I'm going to go ahead and try to draw my line. And this is also equal to, so I can draw a straight line when I do this. Not perfect, but it'll give me an idea. And it's above, so it's going to be like this. So if I have to talk about the triple shaded region, the region that satisfies all 3 of my inequalities, I am talking about I can draw an arrow that's going to go into infinity to right here. So this is the region that I'm talking about when I talk about what satisfies all 3. Okay? Remember that you can't buy half of a light. That doesn't make any sense. If we were talking about solely money here, that may make sense. But X is the number of medium throw lights, and Y is the number of long throw lights. So you can't have halves or quarters or any sort of a decimal part of a light. So I would say, just to check a point, you could have 1, 2, 3, 4, 5 mediums, and 1, 2, 3, 5 mediums and 3 longs. That would get you free delivery. Anything in this shaded region is going to get you free delivery. So if we go down to the last question here, will an order of 4 mediums and 1 long be delivered free? 4 mediums, 1, 2, 3, 4, 1 long. I don't believe that that point is in the shaded region, but let's check. Let's check the point 4, 1. The first one said x is greater than or equal to 3. Is 4 greater than or equal to 3? Absolutely. Is 1 greater than or equal to 1? Yes. And then the last question is 4 greater than or equal to negative 2/7 times 1 plus 20/7? Well, negative 2 plus 20 is 18/7, and 18 divided by 7 7 will go into 18 two times. All right, I have this backwards. Forgive me. You always know when I pause my video there that I found an error in my work. Going live like this is challenging. 1 is your y, 4 is your x. I'm sorry about that. So 4 times -2 is -8/7 plus 20/7 has to be smaller than 1. Well, 20 minus 8, that's 12. So I'm talking about 1 being greater than or equal to 12/7. Well, I can tell you right now that 7 goes into 12 almost 2 times. It goes in there 1 and some change. So that's not going to be less than or equal to 1. That's where it breaks. 12 divided by 7. Seven goes into 57 times 7 is 49. So right there, it's 1 is not bigger than or equal to 1.7. So 4 comma 1 does not satisfy the third inequality. Therefore, 4 medium lights and 1 long light is outside of the solution region, so you will not get free delivery. Since 4-1 is outside of the solution region and does not satisfy y is greater than or equal to -2/7 x plus 20/7, you cannot receive free delivery for 4 medium lights and 1 long light. Okay? Nice job. Good perseverance. That was a tough problem. All right, so what I want from you, I need you to summarize how to solve a system of linear inequalities, how to use graphing to represent the solution. That's something you can go back to your vocabulary and brush up there. How do you interpret the solution? What does that shaded region tell you? Let me know what questions you still have so that I can answer those. And then something new tonight. When you complete your quiz, I would like for you to work out your quiz questions in these 3 spaces. Okay, question 1, question 2, question 3. You can write the problem, solve, graph. This way you have this to use on your test. Okay? Any questions, record them, and we'll talk about them tomorrow. Have a great night.